So imagine trying to mathematically prove a historical miracle, but you anchor it to the Bitcoin blockchain. It sounds like a total science fiction, right?
Okay.
But today we are taking a deep dive into a really highly technical paper about the Shield Protocol 15.2.
Yeah, it is a massive shift in how we handle ancient texts.
Right, and our mission here is to understand how these researchers are merging advanced cryptography, statistics, and linguistics to mathematically map out hidden patterns. And they're doing this across exactly 34,211 verses of the UTV corpus.
Completely decoupled from any theological bias, which is the key. It takes something historically subjective and turns it into a mathematically fixed data set.
Okay, let's unpack this. The protocol relies on a strict commit-reveal cryptography pattern. I mean, if you think about it, it's essentially like calling your shot in a game of pool.
That is a great way to put it. Before a researcher even glanced at the text, they locked down their hypothesis.
Right, you literally have to lock in that mathematically hashed guess before you run the experiment. You log in on a time-stamped ledger, like the Open Science Framework, and for what the paper calls miracle grade claims, you can actually anchor that hash directly into the Bitcoin blockchain.
Which mathematically proves that researchers aren't just, p-hacking or fishing for lucky patterns after the fact.
Oh, wait, I'm trying to picture the actual workflow here. You're telling me researchers have to manually compute these SHA-256 hashes and format complex JSON code files. I mean, I struggle with basic Excel formatting.
Oh, absolutely. It is incredibly tedious.
Wouldn't that massive friction and inevitable user error just kill the project before anyone even uses it?
Well, what's fascinating here is the proposed technological upgrade designed to bypass that exact bottleneck. They outline a complete automation of this cryptographic compliance using the OSF API v2.
Oh, so it just runs in the background.
Yeah, exactly. This middleware does all the heavy lifting. Instead of a human fumbling with complex code strings, this application programming interface acts as a translator.
That is way better.
Right. You type your hypothesis in plain English, click a button, and it instantly mints a verifiable digital object identifier, or DOI, with basically zero user friction.
Okay, that makes total sense. So the experiment is securely registered, the friction is gone, and now we actually have to analyze the text. But the current version of the protocol relies on regular expressions, or regex, which are basically just rigid rules.
Right, which creates a whole new problem.
Because if I am using regex to search for a governance marker, and I type in the word rule, it might flag a king's governance, or it might just mean drawing a straight line. It is like relying on a basic keyword search instead of, actually reading the room.
Yeah, regex is completely blind to context. So the paper proposes a massive upgrade to natural language processing, utilizing something called Shannon entropy.
Shannon entropy.
Yeah, instead of a rigid yes or no keyword match, this uses soft clustering to probabilistically score the underlying contextual vibe of a phrase.
Wow, so it reads the context.
Exactly. So a marker like covenant breach isn't triggered by just one word. Its intensity is continuously scored based on the complex syntax surrounding it.
That is wild. I mean, with smarter text processing, they might find rare anomalies, like the Dominion triad, where identity, inheritance, and priesthood markers all intersect in only 1.44% of verses. So what does this all mean for you, the listener?
Well, you have to ask if it's real or just a fluke, right?
Exactly. If you throw enough powerful NLP algorithms at a massive corpus, aren't you bound to find a pattern eventually? Why go to this extreme level of statistical paranoia?
To brutally crush those exact false positives. They use the triple convergence standard and a mathematical filter called the Benjamin Equutieli penalty.
That sounds intense.
It is aggressively strict. If it detects even a hint that your text patterns are just naturally relying on each other, like grammar rules forcing certain words together, it throws the data out entirely.
Wow, so only the undeniable independent anomalies survive.
Yes. And to make all this heavy math comprehensible, the paper details a shift to D3JS visualizations. Instead of staring at opaque spreadsheets, you get interactive, force-directed graphs.
Oh, I love those visual graphs.
Right. Verses that are mathematically linked, physically pulled together on your screen via statistical gravity. You literally watch the clusters form.
It turns this whole process into an objective visual science. And because the methodology is so rigorous, you can bridge this data directly with databases like the Blue Letter Bible to check the original Greek and Hebrew roots. It really is a fortress of cryptography, NLP, and brutal math.
It fundamentally changes how we verify historical architectures without bias.
Which brings us right back to that pool table. When you mathematically call your shot, lock it in, and the statistical gravity actually proves you right, it makes you wonder. If cryptographic testing and NLP can isolate hidden, non-random architectures inside this specific historical text, what other seemingly chaotic ancient human records might secretly hold mathematically verifiable blueprints just waiting to be decoded?